Well, Mike, it's a great day for a training, wouldn't you say?
Yes, it is.
Great day. Got people coming in. It's that virtual meeting transition, that 1 or 2 minutes where people are getting in, getting settled. But we're going to go ahead and get started because we have a really, really good crowd excited for this webinar. And today we're going to be talking about using NServiceBus to reduce bugs caused by web APIs. And my name is Jeffrey Palermo, and I'm a chief architect at ClearMeasure. I'm joined by ClearMeasure architect Mike Sigsworth. Really excited to be showing this together. And so we're just gonna jump right in. If this is your first time jumping onto a ClearMeasure training, ClearMeasure is a full service software architecture and engineering firm that serves companies using .NET and the entire ecosystem, building mission critical software, rescuing troubled projects, empowering software delivery with a proven approach. So that's ClearMeasure. Quick offer. We have my latest book, The Five Pillars Leadership for Effective Software. If you're in a position where you are overseeing or leading a software engineering team, this book could be for you, and a free offer for those watching. If you'd like a free electronic copy of the book, then just request it in the chat or send me an email. I'd be happy to get that to you. You can find it in hardcover, softcover, audiobook, and on Audible, and then also Kindle. All right, so our agenda for today, um, we're we're talking about the problem if all of our integration just uses web services. And the technology we're showcasing is in Service Bus, which is in the .NET ecosystem the best of breed um, messaging library, messaging platform, uh, tool for distributed applications. And so our agenda is four parts. We're going to talk about the fallacies of distributed systems, which ones of those actually are brought to bear when you just use web APIs to connect every application, every component. Then we're going to talk about the nature of transactions in a distributed world, and we're going to talk about the unique characteristics of long-running processes. And just wanted to give a reference to the podcast, the on the Azure and DevOps podcast. Udi Dahan came on as a guest talking about distributed computing. That's episode 192. So you can go to Google Play Podcasts, Apple Podcasts, or you can find that on YouTube, episode 192 of the Azure and DevOps podcast. All right. And let's back up from just the technology in service bus, web APIs, queuing, all that. Our overall goal is that we're moving really fast in our project. And we want the curve on the left, where the further we go, the faster we're able to deliver. We don't want the logarithmic or the slowing down curve on the right, where the longer we go, the slower we develop, because there's so many production issues being escalated to the engineering team that we just fight for time to work. And so the accidental overuse of web APIs contributes to an unnecessarily high rate of production issues being escalated to the software engineering team because some wonky things are happening in production, and the data is inconsistent, and the regular support people can't sort it out. And so guess what? It gets escalated to the engineering team, and now somebody has to stop working on the next feature and figure out what the heck this problem is. And an overuse of web APIs is one of the culprits. So let's go through the 8 fallacies of distributed computing. Um, and way back in before this, but in the early 90s, Peter Deutsch made these kind of famous. He was at Sun Microsystems, and he did a lot of talking about it, and you can find him online. And Udi Dahan has also done a lot of speaking on it, and many others. But let's just go through them real quick. Uh, a fallacy, a mistaken belief that the network is reliable. Actually, networks can fail, and they do fail, and systems have to be designed to handle these failures gracefully. Another mistake is thinking that latency is zero between components. In reality, communication between distributed components, it takes time. and the latency has to be accounted for. Another mistake, a fallacy, is that bandwidth on the network is infinite, when in reality, network bandwidth is not, and systems have to be designed to operate efficiently within whatever constraints you have. Another fallacy, a mistake, is the thinking the network is secure, when in reality, security risks are inherent in distributed systems, just like in every system, and you have to protect the data and the communications. Another mistake is thinking the topology of the network and the systems don't change, whereas the network topology will change when there's failures, when you make adjustments to scaling characteristics and other factors. So the system has to adapt dynamically. There's also a mistake to think that there is one administrator in a distributed system, where in reality, a distributed system is made up of multiple applications, and there's going to be multiple administrators with different policies and configurations. Another mistake is thinking that the transport cost is zero between components, and that's not true. Data transfer has costs where monetary, if you're using Azure, I mean, you can calculate the cost of moving data from a region to the other. There's also performance impacts. Another mistake is that the network is homogeneous, when in reality, networks are mostly heterogeneous with lots of different types of hardware, software, and protocols. But if you go through assuming that these are actually true, that's why we call them fallacies, then you might have conversations amongst the team, and you might decide, oh yeah, let's just use web APIs for everything. Let's just spin up a web service, connect them, boom, boom, boom. I got everything talking, works on my box. Hey, works a lot of the time just fine. Until the system gets put in the real world with real world demands. And in several of these eight fallacies are particularly relevant when we're working with web APIs. And uh, six of them have a direct impact on making mistaken decisions to overuse web API, and just showing these on the screen, the ones that'll really get you. All right, so we have a demo. We don't have a lot of slides to show, but we are going to show a demo, and um, and here's the shape of it, and we'll come back to it. We're going to come back to this slide right before I pull in Mike to give us a briefing, but overall, we can connect components directly with a web API, but oftentimes, if we want to decouple those components, so that if component B goes down or has a slowdown, we don't directly end up making the user wait. And so we put a queue in between. And let me forward over to the three demos we're going to give you. We're going to give a demo of async request response, because the problem with a transaction when you're using web APIs is, what if you have two different system calls? In distributed systems, transactions refer to a sequence of operations that have to be completed in a single unit of work. And if any of the operations in the sequence fail, the entire transaction needs to be rolled back to maintain consistency. And this is referred to as ACID, which stands for atomicity, consistency, isolation, durability. These are some really old concepts. And when you're using web APIs, we often struggle with transactions because there is no such thing as a distributed transaction. We have coupling problems, error handling, latency and reliability, and transactions over web APIs are vulnerable to network latency failures. And if a network issue occurs during a transaction, it's going to leave the system in an inconsistent state. So we're going to show you a demo, or we're going to talk through a pattern for that. And um, we're also going to show how to handle long running processes. And Mike's going to show you that code. But on the technical side, we don't want to keep HTTP connections open or blocking those threads. Instead, we want to break the processes into smaller, manageable steps using queues to coordinate those steps. And this approach allows systems to process tasks asynchronously and reduce resource contention and improve scalability. And really long running processes, those can always be divided into smaller and discrete steps where each of the stages is represented by a message in a queue, and then the message are processes they're processed independently, and then the system can use polling or callbacks to notify the client of how much progress we're making to completion. And this design avoids the pitfalls of synchronous communication, which web APIs are synchronous communication, involves those pitfalls and ensures that the system really remains responsive to the user under heavy load, even if some bad things are happening one or two components away. So let's go back, and I'm going to bring in Mike to show the code. Um, and and Mike, you've been working with NServiceBus daily, every single version for what, a decade?
Pretty
And
close.
so and so I can't think of a better expert to kind of show how it's put together. So excited to have you showing this with me.
Well, thank you for that introduction. I wanted to add a few things too. Uh, when you're just dealing with all APIs, what you tend to build is a house of cards where you have APIs that depend on a chain of API calls. Anywhere in there, one of those APIs fails and it will bring down the entire request. So that first service that you're hitting, it might be really quick in doing what it needs to do. But if it depends on one or more API calls, that may depend on more API calls, then all of those network fallacies come to bear, especially the one about timeouts and latency. If you have one of the services in there that's having trouble and it times out after a minute, well, your entire request is going to time out after a minute. And then you're going to have to resend that API, have some sort of retries or error handling on the front end or whatever client is calling it. So building a house of cards out of a chain of API calls is definitely, I don't like to throw the word around anti-pattern a lot,
Mhm.
but it is definitely an anti-pattern. So if you want to use messaging to try and solve those problems, then one of the things that you have to embrace is um, eventual consistency. So typically you would think, I'm going to call this API and tell it to save this record, and I expect that record to be saved when I get the response back from the API. But what we're going to show here in the demo is when you call the API, instead of having the API do the work, it will defer the work to an asynchronous messaging framework, NServiceBus, so that it processes the record and saves it to the database asynchronously. So the front end has to be able to deal with that scenario where it's going to send a request to do something, and then there's another endpoint it could potentially pull for the status or to get the entity back. That's how I've implemented the demo. You could use like WebSockets to call back to the front end, but that can be very expensive as your user count increases. So the demo I'll show today is going to demonstrate a bunch of these things. And then we'll get into Saga as well later to talk about that long running business process. So I will go ahead and share and start showing the code.
Yeah, let's switch over screens.
Make sure I choose the right screen. Jeffrey, do we see GitHub on the
Yep.
left and Visual Studio on the right? Okay, perfect.
Yes, we do.
So I just have GitHub showing here that if you want to see the code, we'll share this link, but this is all publicly available and relatively well documented here with some diagrams that walk through all the different components and how they work. But I won't touch much on that. Let's just go right to the code. So I'm using an app called Seek, which is a great way of just viewing local. I use it mostly for local, but it's a log search utility. But this is going to show us our logs in real time as we go through things here. Um, a quick lay of the land of the solution. So I'm using a vertical slice architecture. So it's essentially very small. We have an invoicing project, which is a service that has a single handler in it. It's running on NServiceBus and a console application. Orders is both a web API and an NServiceBus endpoint running in the same process. I would say ordinarily you would split out those two, have an API as a single application, and then your NServiceBus endpoint running as a separate one. That way you can scale them independently. You don't want your load balancing of your API, for example, to affect the scaling of your backend processing. So it's good to decouple them, but for a simple demo, I just put them both into one place. And we got some shared projects here just to share some common functionality. I will call out the shared messages project. It has a few commands and events in it. And it's good to put certain messages in their own shared library. Typically, you would publish this as a NuGet package so that anyone that's interested in consuming that event can get the contracts through that shared NuGet package. But you don't want to put all of your contracts into the NuGet package because some messages are just going to be internal to a service. So you'll notice that there's some contracts here, but there's also some contracts that are internal to this orders application. So to start off, we're going to send an HTTP request to our web API to submit an order. And an order is simply defined as an order number with some just random information that I invented to throw on there. But the order number is it's not the primary key, but it is unique. We never expose the primary key, the ID value outside of this API, as I think that is a good practice. The user is going to supply the order number in their request, so they will always know how to get the order back based off of their order number. And then the response here, we do send a response back from the call, but it's simply going to have a message that indicates it's processing and it's processing this order number. The API endpoint, since I'm using vertical slice, if you're not familiar with the technology or with the architecture, sorry, I have a static class called submit order that wraps all of the bits and pieces. So everything that we need to build out this single feature is all in one file. So it's a nice way to build a very quick microservice and keep everything in one place. All the things that need to change stay together, nice and cohesive. Okay, so when you send your request in, it hits this API endpoint at this path, and it calls the handle method here. We've got some dependency injection of the things that we need. Very first thing we do is just quickly check in the database and make sure that there isn't a duplicate record. If there's already an order with the order number, then we're going to return a 409 conflict. Otherwise, we're going to translate the API request into a command, and this is an NServiceBus command. And we will use this message session. So the message session is your injected interface that allows you to send and publish messages from an API. Typically from an API, you could use it outside of an API, but this is typically what you'll be working with when you're dealing with a web API, sending NServiceBus messages. And send local is a shortcut to just send it to the endpoint running within the current process. If I wanted to split them out, I would have to use send and configure some routing and things like that. So again, I wanted to avoid that complexity for the demo. So finally, after we send that message off, we're going to return a 202 accepted response. And with the message here, order received and is being processed. And there's going to be a location header on there that will point to the get endpoint that we'll need to use in order to get the actual record once it's finished being created. And this handler, sorry, this command here will be, this is the command definition, and here's the command handler. So NServiceBus has an I handle messages interface, and you specify the command that you're going to be handling. And you might think it's silly to just have it called command, but if you do hover over it, you can see that it's technically submit order dot command due to the nesting inside the static class. And then here's the handle method. So the handle method will get a message handler context, and the message handler context, all of the stuff that's happening inside this handle method is now being performed inside a database transaction that's governed by NServiceBus. And the message handler context has a bunch of other stuff on it that we can use to communicate back with NServiceBus. So if we need to publish more messages, events rather, or send more commands, we'll use this context to do that, as opposed to the message session that we used in Web API. And we can get into a little bit more of why they're different when we start to talk about Outbox. Okay, so right off the bat, we're just checking to see if we're in delayed retries here, mostly for demo purposes, not something you would have in production code. Neither would this be adding in a fake delay of 5 seconds, just trying to simulate some sort of network latency. But the meat of it is we're just going to store the order in the database. We're actually not doing any validation here either. We should, but for demo purposes, I wanted to be able to elicit some sort of a failure. So we're not actually checking the database again to see if the order is unique. Always validate your inputs is the golden rule, and we're not doing that in the demo, but you ideally would do some additional validation logic in your handler. So validate in the API and validate in the handler. So finally, we just are adding the orders. We're using Entity Framework here, adding it to our orders collection, newing up our primary key value, not using identities or anything like that in SQL. It's just a GUID. And then save that to the database. And we will simply handle the update exception that we'll get to later, but we're going to rethrow it again so that we can talk about NServiceBus retries. And then finally, after that, we publish the message. Okay, so that was a lot, but really high level, we have an API request, comes in, sends a command, NServiceBus handles the command and does two things. Saves the record to the database, and then it publishes an event that says, I just did a thing. And by publishing that event, anyone can subscribe to that event and do whatever they need to do based off of that thing happening. So in this case, order submitted is going to go and trigger a few other things. But before we start diving into more code, I want to run the solution, and we will just look at the logs and we'll go through the happy path scenario here. So another new thing for me that I started to use for this demo that I thought was neat were these HTTP files, which is relatively new for Visual Studio 2022. New to me anyways, but I think it is relatively new. This is a quick way of saving the requests that are available, and I kind of built them into these two different test cases. We've got duplicate order and we've got happy path. So instead of building out Postman and having a Swagger endpoint and all that stuff, just very simply have this file that we can execute these requests. So the very first one is submitting the order. And let me just make this a little bigger so we can take a peek here. So this is the response that we got back from the API. There's that message, order received and is being processed, and here's the order number. Now we actually submitted this order number in the request, but it's helpful to remind the caller of the context. And the header has this location, which is just pointing back to the service and telling the endpoint where the caller can go to get the status of it. Now, I figured this would happen in all that talking. Let me just collapse the Solution Explorer here. That we triggered our expiration saga. So I'm just going to send another request before we dive into the saga. So we send a request, and then here we can go and pull this get endpoint. Now, the first time I hit it, you can see it says it's not found, which is the eventual consistency. And this is something that you kind of have to be able to embrace if you're using this sort of backend asynchronous message-based architecture. But the next time we send the request, that simulated 5-second delay that I put in there has since elapsed, and there, boom, we have our record and the status is submitted. Now, the next step in the workflow is to accept the order. And if you wait too long, in this case 30 seconds, the order will automatically be expired. And Jeffrey, do you want me to jump into the rest of this, or do we want to go back to just discussing any of the simpler aspects of this first before we talk about SUG?
Yeah, no, that's good. I think one thing that popped out in my mind was just for someone who's only ever done web APIs before, it could be, oh shoot, man, this is a lot. This is way more complicated. I could just, if I'm just saving the order to a database, I mean, I can just put that Entity Framework code right there in the web API controller and I'm done. Why is it so complicated? But once this thought process matures and fully soaks in, it's the realization that, okay, I may put code in a few different places, but it actually makes it simple to run when you have things happening in production and the next system down or the next system down has a hiccup, and now we've decoupled those things. I think that's like hidden in this simple code is that big idea.
If you're running in a high performance environment, like let's say Kubernetes or even just an Azure container app where you're scaling things up and down constantly based on user needs, uh, it could be that your API that took that request in needs to scale down for some reason. And if you have any requests that are going on and they're long requests because they're doing database logic and storing things, then those requests are going to get terminated. And now you're relying on your caller to have some sort of retry logic built in, which is fine. You know, you can develop like that. Plenty of reasons to do that. But one of the things that this buys you, having this backend processing, is you have these very snappy requests. Your API layer is not doing a lot of work. It's just taking the request and dispatching it to a command. I could send the request in, I could shut the entire thing down, and then when I start the stack back up, those messages are still in the queue as well. So if my backend processing queues fail, when they start back up, it's all durable messaging. It's going to reconsume those commands and start processing them. You also get lots of retriability and error handling and things like that out of NServiceBus. So it's more robust, but it is definitely more complicated.
Yeah, so it's the simple case where I just want to have component A send send it. It looks like we're just sending a C# class that under the covers is being serialized, but we're just here's a C# class and transparent serialization, and then I have another process and a class that inherits from the handler interface, and pretty much that's it. It just gets routed automatically by in service bus, and um, I mean that is actually very simple.
I would imagine that a lot of the people watching have heard of or used Mediator before, and this is no more complex than Mediator. Mediator, you're going to send commands and queries. This is the exact same idea. It's just whether in Mediator you want to handle those requests and queries in process versus NService Bus doing them out of process in some asynchronous background.
That's a good point. Mediator does synchronous in-process routing, and you're on your own if you want to remote one of those calls to something that's not in the same process. Whereas the whole world of in-service bus is the routing is always remote and asynchronous and durable delivery.
Yeah.
So
I think you can also use both Mediator and NService Bus. There might be good reasons to use Mediator so that you can have synchronous API calls that do some work, but then also dispatch events that will go to your backend processors that NService Bus are facilitating.
and one of the fallacies we talked about was distributed transactions. And in the past, Microsoft has even had a product called Distributed Transaction Coordinator if you were using the right set of Microsoft products that could do things just so. But in reality, when you've got, a cluster of systems that are run by different people and you're trying to then call maybe a PayPal web service to do or if something fails midstream, distributed transactions aren't actually a real concept. You can't enlist systems from all kinds of different vendors in like a literal transaction. So what's the thinking here using in-service bus when you need to recover if, step two or step three goes wrong?
Yeah, absolutely. When you're dealing with an API call, well, you still have the same problem inside an NService bus handler. If you are calling an API that's mutating something on its back end, like calling PayPal and submitting a payment, That's not part of your transaction. There's no rolling that back. You need to do what's called a compensating transaction if you need to roll that back. And those are cumbersome and difficult to design. So if you're using NServiceBus, what you could do instead is have a command that starts your process that, let's say persists the order to the database, and then it dispatches this order submitted event. What we'll see next in the demo is the order gets approved, and after the order is approved, we're triggering this invoicing service to go and send an invoice to the customer. So rather than calling PayPal, we're sending an invoice to the customer. Now, if we had built this all in the API and we had gone and sent that invoice to the customer, part of our API process, and something failed after that, well, we've now sent an invoice to the customer, but there's no invoice stored in the database. So this is where something called the outbox comes into play. And the outbox is really just another database table that lives within your application data. So if we save an invoice to our database, in that same database, we would have a table called outbox. And any messages that are published as part of the process, the same transaction that's storing that invoice, are also going to store their messages into the outbox. And then the transaction commits, and you have everything safely in the database. And you have another process that's polling the outbox. And NServiceBus offers this for free, by the way. So you just configure your endpoint with the outbox, and then any outgoing messages go to the outbox. And NServiceBus is very transparently, you don't have to configure it. It's just monitoring that outbox table to see, hey, are there any messages that haven't been sent yet? And then sends them to wherever they need to go. So the outbox gives you that durability of outgoing messages and the atomicity around your business processes. So to tack onto that, the so to send the invoice, you would have that in its own message handler. So you would have like a send invoice handler that was looking for that order approved event and responding to it. And its sole purpose would be to send the invoice or call PayPal or whatever it is. Keep your external API interactions, excuse me, isolated in their own handler, so that if that handler has any failures or any need to retry, it's just doing that one thing. So that's a good way to sort of compartmentalize your handlers properly in a distributed system.
So the outbox pattern, and we've called it a pattern, not a component. What are the classes here in the demo that are there because you're wanting to use the outbox pattern, which is again, it's a design pattern, so it's not a library, it's not a tool, it's just a way to do things.
So, well, very simply, I will open up the NServiceBus configuration. I don't want to look at this too long because certainly don't want to explain all of this. But in order to enable Outbox, that's all you need to do. Okay, it's just a simple enable Outbox on your endpoint configuration. And it handles building out the database infrastructure. It handles spinning up that background process that needs to pull the outbox and do all of the processing of those messages. But where it's going to save us here, and this is where the differences between that message session interface and the iMessage handler context interface come into play. So a message session is bare bones. It does not participate in the outbox. So from your API, you still want to be cognizant of the fact that there's no outbox pattern. So if you were to want to save some data in your API call and then publish in a message, you could still wind up in a scenario where one or the other of those things happened and one didn't. There is something called the transactional message session that you can implement that would allow you to have the outbox in your API calls, but I did not implement that today because everything is deferred to the handler, and the handler is using this context, which does have the outbox enabled on it. Apologize if that's a little bit confusing, but um, yeah, let's move on. So
Yeah, let's move on to the long running process because rather than chaining together multiple web APIs and then dealing with all these things and performance problems, a lot of times there is a system a system down the chain where it is never gonna it's never going to come back in 1 second, 2 seconds, even 1 minute. It could be that, it takes an hour or it takes longer. And and if I'm just using web APIs, well, then what do I have to do? I have to hand roll my own queue pattern. I have to create a new database in a table, and now I have to put something in there and say, okay, this is my beginning status, and now I have to have some other process hand rolled by hand coming back and checking, okay, I got to do this next thing. Um so yeah, let's look at what it looks like and how simple if using in service bus.
Sure. It's been a long time since I've needed to handle time-based scenarios outside of NServiceBus, but there was a framework that I used a long time ago. I've completely forgotten the name of it. It's a .NET framework that you would build sort of a cron job kind of thing on top of. You know what I'm talking
Is it
about,
the top
Jeffrey?
shelf?
It's not Top Shelf. It was totally related to that, though.
There's been a number of them. Yeah.
Maybe it was Top Shelf. Yeah.
Because
So,
it's a common problem.
right. So, do you build a cron job in your server, or do you maybe use a SQL job and set that up on a schedule? So handling things that need to occur either at a specific time or after a specific duration is something that you can solve within Service Bus using a saga. So the saga in our case is this order expiry saga. And again, this is durable. The saga and all of its state are persisted to the database by NServiceBus. If you're a fan of domain-driven design, you've probably heard of sagas before, and I think people have used these and service bus sagas to implement aggregate routes and things like that. So you can get real complicated with these things. But in our situation, we have a saga that is started by messages order submitted. So after we publish that event, this is one of the things that's subscribing to it and responding to it by starting a new instance of the saga, which hits this handler here, which very simply will just log a message and then it requests a timeout of 30 seconds. And that's called the order expiration timeout. And then the saga goes to bed. It's no longer in memory. It's just there in the saga storage in SQL Server. And after 30 seconds, there's a delayed message, and the N-Service Bus framework is kind of handling all the timing of this for you. Um, More accurately, the transport layer, which I have running in SQL, is handling the timing of this for you. It will essentially send this message when it's time, and that order expiration timeout is a message. So when it gets sent, the framework will tie it back to this saga. It will rehydrate the saga from the database, and it will handle the timeout. And all it's doing to handle the timeout is sending another command. So in here, it's sending an expire order command. And the expire order command goes to another one of these vertical slices, which simply has a command handler in it. And the expire order command will go and grab the record from the database, make sure it's not null, and it'll check the state on it. So there's better ways to develop a state machine, but this is obviously very simple for a demo. We're just kind of going through in a switch statement, checking the different statuses that this order is in that we just retrieved from the database. So if it's already been approved, then we say, well, can't expire it. It's already been approved. So we can just log a warning, return, and ignore.
Let
If it's
me
already
this order expiration. This scenario, some people might
Mhm.
think, why are you expiring the order instead of processing it? And there's a on like Sweetwater.com has used audio equipment sales, and I've sold something, and it has one of these things where they may have listed it on Facebook Marketplace, Craigslist, Sweetwater, and you put in the order for this piece of used equipment, but then the owner of it actually has to come back and says, yes, I still have it. Yes, I'll sell it to you. And
Yeah.
so in those kinds of cases, unless it's approved manually somehow, the order can't go through. Whereas if we just think, Amazon, we might be confused, like, why would you expire an order?
Yeah, or maybe you work in a sales department and you're selling 1,000 units of some, pricey device, and you need your manager approval when you're selling more than a certain number of units
Yeah,
or something.
yeah.
Your business logic could be anything. This is very simple. Uh, I agree, though. It's it's a bit of a contrived setup that I
It's a
have.
demo.
Yeah. All right. So if the order is already expired and we're trying to expire it, no need to do that again. So we want to bail out of that early. Otherwise, we would threaten, republishing or resaving when we don't need to. So save some resources. Just bail out early if it's already been done. And actually, this is another one of the network fallacies and something that you have to kind of get used to with messaging in general is that you could have duplicate messages. You could have multiple commands trying to do the same thing, and you want to be able to gracefully handle when the situation has already occurred. The outbox offers deduplication as well. So if it's an identical message, like literally the exact same copy of the message, and not just the client hit the API twice, creating two different messages to do the same thing, the outbox will deduplicate those things for you as well. All right, so the meat of this action is save the update. So we're setting the status of the order to expired, saving it, and publishing an event. So just to really drive home the outbox and why it's there, there's two well-known concepts that you can see in situations where you have a distributed transaction, or maybe something can't participate in a transaction. And the first one is called a ghost message. So a ghost message would be if we reordered these lines. Let's say we published order expired first, and then we saved to the database second. If the save to the database failed, but we've already sent the message, then we've sent a ghost message out to the system. Everybody thinks that something happened, but when they go and look for that thing in the database, it's not actually there. And then the other one is totally drawing a blank right now. Ghost message and zombie record.
Zombie.
Yeah. So a zombie record would be if it's in the order I've got them here, you save to the database first, but then never tell anyone about it. Your publish fails, the event never goes out. You've got this zombie record in the database. No one knows about it. So having an outbox allows you to make sure that these two operations are part of the same atomic transaction. All right, let's do a little bit more of the demo here. I'm just going to clear out the logs because we've been doing a lot of talking and all this stuff has been going on over here. So the happy path is step one, we're going to submit an order. Then we're going to pull the get endpoint to get the order details. And then so long as we do it before 30 seconds, we can approve the order and then we can get the details back and see that the status has been updated to approved. So without further ado, send our request. We hit the endpoint, it's first 404 not found. Now we can see that the order has been saved to the database and the order submitted event was published. And we got back our record of submitted. Now when we approve the order, we can see in the logs here that we're approving order, blah, blah, blah. The status was updated to approved, order approved, event published. And then here's our creating invoice for accepted order, which is happening over in a completely different process. This is a different application, and it is using SQL native pub sub in order to subscribe to this. But it's very simple. It's looking at that order approved event, which is in that shared messages library, and it's just logging something. And we could obviously do something more complicated here, but just for demonstration purposes, we're triggering a process in a completely different handler. No API calls required. This is all eventing. All right, now let's do the expiration. An expiration is very simple. We just do step one. We can see here that the API request was received. We sent the command to submit the order, handling the command to submit the order, and the command saved it to the database and published an order submitted event, which then started the order expiry saga. Now all we have to do is wait 30 seconds and we will see the saga timeout kicking in, which sends the command, the expire order command, to process the expiration, which will actually do the work of updating the database record and then publishing the order expired command. And by publishing the order expired command, we now give ourselves another seam in the application where people can respond to this expiration event. Well, maybe we want to send an email to the person that submitted the order and say, hey, apologies, your order was expired. Maybe you want to try resubmitting it, or, invent your own business logic there. But it gives you this ability to trigger other processes. The nice thing about event-driven architecture is that you don't have this giant class that's orchestrating all these things, saying, well, first I submit the order, and then after it's submitted, I got to call this thing over here to, send this thing. And when that happens, then I have to go and call the customer, send them an email. You don't want to have all those um, concerns in one place, right? This is the single responsibility principle. You just put things in the necessary components and tie them together through event-driven mechanisms. All right, so we see that the order status was updated to expired, and the order expired event was published. That order expired event goes back into the Saga. So let's go back to the Saga code here. We can see we have a few other event handlers for the different events. So if it's approved, all we're doing is logging a message and we're marking it as complete. But suppose there could be some other functionality that we wanted. Same thing with expired. When it's expired, we're simply just completing the Saga. And all mark as complete does is it deletes the Saga from the database. It's no longer needed. It doesn't have a useful purpose. You can delete it. In practice, I typically don't delete Sagas. You typically don't delete data from a database. It's good to have it there for auditing and history purposes. So, but again, for demonstration purposes, needed something to do in order expired without inflating the demo any further. So I do have a brief thing I could talk about with failure scenarios and retries, Jeffrey. If you want, I can dive into that, or we can go back to the slides.
Yeah, let's just go back to the slides. We can talk about that, but let's go back to the slides. So let's
Sure. I will stop sharing.
share this. All right, I think it's back up. And I wanted to highlight too, now that people have seen the code in action, just the shape of it and how this diagram is very different from the diagram if you were to connect the ordering system and the invoicing system together with just web services, where you would have somebody on an e-commerce website putting in an order, they click a button, and now before that button click finishes, they have to wait for the ordering system to do its processing. Then they have to a some type of human-based approval step wouldn't even be possible in that scenario. But if it was automated invoicing, then it'd be another hop over to the invoicing system. And if anything was going on with the invoicing system or some of the logic for ordering, well, now that e-commerce system will seem sluggish. And any of the successful e-commerce systems, you will be able to tell when using it right off the bat, they are not chaining systems together using web service calls. They have queuing in the architecture, because the successful ones, there's no way they'd even be able to function if they did not put queuing in their architecture. So we've talked about the nature of transactions. We talked about the long running processes, and and I want to ask you, Mike, about that scenario, but I wanted to emphasize what it might feel like if you're misusing web APIs. If production issues, if every week you get some number of issues escalated to the development team, and the result is not to do a code hotfix to actually fix a code bug, but you have to go in and tweak some data, or you have to fix a record somewhere, or you have to restart a process. You have to do something in production because somehow something got in a bad state. That right there should be your blinking red lights that you don't have a code bug, you have an architecture bug. And if you have a lot of web services and you're chaining things together with web services, you probably want to look real closely at what you're doing there, because that might be your culprit. But that's your warning. So If your team is not, if you don't have a scorecard where you're actually recording the number of production issues and the ones that are because of a business disruption, where you can actually look back and see, oh yeah, okay, these are my stability metrics and this is how many of these issues over time, then go to our website, clearmeasure.com, grab our scorecard template, just get started tracking your actual basic metrics for your software team. And this can help you identify that, hey, maybe you have some architectural bugs, not just code bugs, architectural bugs, and this might be one of them. So I'll kind of leave that up, Mike, while you emphasize your point.
No, I just wanted to say it always comes down to coupling, doesn't it? Right? If you have APIs coupled together, you've got a whole long running process that's temporally coupled to each other. And by distributing things out, you can solve that coupling issue. Of course, you always introduce one issue after solving another issue. So there's always going to be trade offs. It's not like the time issues suddenly vanish when you put everything in background processes. In some cases, it can make it less visible, which is why when you're distributing and doing an event-driven system like this, you need to have things like open telemetry and Azure App Insights and monitoring. So building microservices is not for the faint of heart, but it does give you a more stable system in general terms, and typically a better, more decoupled architecture if done correctly. Yeah,
Yeah.
so I just wanted to talk about retries and NServiceBus. Um, One of the things that I had talked about earlier, if you have your API call fail, you're really reliant on the caller to reattempt that request. And sometimes they just won't. Maybe they'll see your service is failing and they won't try it again. Or you're really you're passing the buck, right, to the client to do the right thing. Whereas if you can defer your business logic to these message handling scenarios, then the scenario we had built in the demo was more of what you'd call a persistent failure, where we get a message and that message goes and tries to save a duplicate record to the database. And the database has a unique constraint on the order number, so it throws a SQL exception and saying, you're violating this duplicate key and you can't do this. And in that case, whenever there's an exception that is thrown within an NServiceBus handler, the message will go back to the queue and it will be immediately reprocessed. So there's two levels of retries that NServiceBus gives you. So that immediate retry, and you can configure it to do it 1, 2, 3, 10 times. It will essentially just keep hammering on that message and try and process it over and over and over again. That is great if you are, let's say, calling some other API and the API is down or it times out and it fails and you want that retry to come in and fix those sort of transient failures. The retry mechanism in NServiceBus is great. Unfortunately, the demo I had today was more of a persistent failure that's never going to be recoverable. That record is never going away in the database. You're never going to be able to store it twice. So you want to be able to sort of escape early in those situations. So you would have some sort of error handling to and validation and things like that. You can never escape validation. But the transient failure scenario and service bus has all that retry stuff built in. If you're doing it from an API, you could use something like Poly, and you should try and use Poly if you want to automate retries in an API. But again, it's just another thing that NServiceBus bakes in for you. And it's one of the best reasons to use a framework if you're trying to build a complicated message-based event-driven system. You could go and use RabbitMQ directly or Azure Service Bus directly. But the amount of time that you're going to spend building all the bits and pieces that NService Bus will just provide for you, um, it's very time consuming and getting
Hmm.
it right. And why reinvent the wheel when someone has uh, built all these tools for you? So retries, Outbox. We didn't talk about, NService Bus has this thing called their service platform, and it's a
Yeah.
suite of tools. You can go and look at the error queue, see what messages failed today, retry them if you need to. There's service insights that will show you these diagrams of all the interactions of your events and how your saga did its thing. So they have some incredible tools for, peeling back the covers and seeing what's going on in your message-based system.
Yeah, that's a good point. And there's no way we could cover everything here. But as we close up, um, the programming paradigm, if any of you have never done any kind of messaging before and your whole world is web services, then one big thing that's different in just the programming experience is the movement from methods calling methods to sending objects to abstractions. And that's going to be big. But if you just remember back to when you learned what this thing was that's called object-oriented development, when you move to commands and queries and events and messaging between systems, you benefit from making everything an object. And you define what needs to happen as an object, as a little chunk of data and is for a purpose of something happening. And then you send the object to an abstraction, which then, NServiceBus provides that abstraction and routes it to a queue. And then your handler is polymorphism. You inherit from the handler interface, and then that's used for routing those objects that are, a bucket of intent for something to happen. And Service Bus routes it to the concrete implementation. So that's a big thing is it's kind of a mindset change, is moving from integrating and chaining things together where method calls a method calls a method to defining everything that's happening as an object, and you send the object to an abstraction. So just want to mention that as we close up. And last last item here. Um, Again, the Five Pillars book, it's all about software leadership. And if you are a senior engineer or an architect or run a software team, we would love to get this book in your hands. It's a very easy read. We've gotten great feedback from when we published it in um, December, and we have a software leadership training course that's going live very quickly. So if you're not subscribed to our newsletter, then you can just go on clearmeasure.com and make sure that you get plugged in. And and we're so excited for all the people that came out live, and we're also recording this, so we'll be posting this, so you can send it to your colleagues and friends. But yeah, thanks so much. And Mike, it was awesome to kind of showcase this with you today.
Yeah, thanks for having me, Jeffrey. Appreciate it.
Awesome. All right, everyone. Thank you very much for joining today's training, and see you later, and God bless.